Good afternoon, Aniket. Welcome all of you. Now we start. That in our last lecture we tried to discuss about potential division, but due to so much interruption, I have to revise it again in short. That is potential division. Okay. So whenever two or three resistances are connected in series, potential drop across each resistance is given by the formula. That suppose V1 is the potential drop across R1. Before that, R1, R2, R3 are the three resistances in series. Okay. Shall I wait for 1 or 2 minutes for other students to join? Only 4 are there. Today there is a new timetable. All of you are aware of that, about that. Okay. Okay, Gaurav and Ritesh. In the morning, how many lectures? 8 to 9:15. After that, 9:30 to 10:45. Then 11 to 12:15. Okay, these 3 lectures. And this is your 4th and last lecture, right? Yes, only 3 live. That's why I'm going to wait for 1 or 2 minutes. Sanskriti, okay, welcome. Rupesh. Yes. Today very interesting topic we are going to study and try to simplify. I know you like all that mathematical calculation. म्हणजे आज जे शिकणार आहे ते तुम्हाला आवडेल करायला. And long term we have to implement that mathematical calculations of potential division and current division. We try to simplify that. First we study the principle of current division. Yes, I already shared everywhere. Wait. I already shared link in all 11 groups. Okay. Vipul. First time Vipul name I heard. Vipul, do you see previous videos? Are you an 11th electronic student? Okay. Those who are live, maintain live. Don't leave the class now. Okay? Okay, welcome all of you and good afternoon again. Now we will start. Suppose, now listen carefully. How सांगते मी? Whenever three resistances whenever three resistances R1, R2 and R3 are connected in series, V1 is the potential drop across R1, V2 is the potential drop across R2 and V3 is the potential drop across R3. Okay, and overall potential of battery of potential V is applied across that series combination. Okay, so V is equal to IR. What is the formula for that series resistance? Total series resistance is given by RS is equal to R1 plus R2 plus R3, and we know overall potential V is equal to I into RS, because RS is the overall resistance of this series combination. Therefore, what you have to write that V is equal to I into RS. Okay. Now, for that V1, we have to find out the formula. V is equal V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. Means I is the current through R1, I is the current through R2, and I is the current through R3. Therefore, V1 IR1, V2 IR2, V3 is equal to IR3. Therefore, we insert all these values here in this equation. RS is equal to V upon I. Therefore, we get V is equal to V1 plus, or we want to find out for V1. Okay, we want to find out for V1. So, how you write V1 upon V is equal to IR1 upon I into RS. Therefore, V1 is equal to R1 upon RS. I cancel into V. Therefore, V1 is equal to R1 upon R1 plus R2 plus R3 into V. Okay, this one is a formula. Write down first with me. Write down all these things with me. What is potential division said? Potential drop across resistance R1 is given by V1 is equal to, do you see this? R1, R2, R3. This is your R1, this is your R2, this is your R3. Is it visible now? Okay. So, V1 is equal to R1 upon R1 plus R2 plus R3 into V. How you write V2? V2 is equal to R2 upon R1 plus R2 plus R3 into V. What is V3? V3 is equal to R3 upon R1 plus R2 into R3 into V. Okay, this is known as a potential division. You understand what potential means V? Division means how it is divided. Overall potential V, how it is divided? V1, V2, V3. And what is the formula for V1, V2, V3? Similarly, if we take the division of V2 upon V, then we get V2 is equal to R2 upon, write down all these steps. Therefore, if V2 upon V, then what is V2? IR2. R2 upon V is equal to what? I into RS. Therefore, V2 is equal to V2 upon V is equal to R2 upon RS. Therefore, V2 is equal to R2 upon R1 plus R2 plus R3 into V. In place of RS, we insert this. RS is equal to R1 plus R2 plus R3 here. Okay, therefore this is the second formula for potential division. Now similarly, if we consider V3 upon V, then what is our V3? I into R3. Therefore here we insert I into R3 and V is equal to I into RS. Therefore which is equal to R3 upon RS. Therefore V3 is equal to R3 upon R1 plus R2 plus R3 multiplied by V. This one is formula for potential division. Potential V is divided as V1 plus V2 plus V3. So what is the individual potential drop across resistance R1? It is given by R1 upon R1 plus R2 into R plus R3 into V. Here what is V2? R2 upon, while for सेकंड रेजिस्टन्स असेल तर न्यूमरेटरला सेकंड रेजिस्टन्सच येणार आणि उरलेले जेवढे सिरीज मध्ये ते कुठे येणार डिनॉमिनेटरला ऍडिशन मध्ये अँड मल्टिप्लाय बाय ओव्हरऑल पोटेन्शियल V of that actual potential of that battery. Okay, so write down fast. We try to simplify numericals related to this. Okay, within half minute write down this one. Yes, I repeat it. Okay, Gaurav, don't worry. Listen here, Gaurav. Whenever three resistances, there may be two resistances, there may be three resistances, there may be four resistances, any number of resistances, but in series. Okay, V3, na? Don't worry. Again, I repeat. I think in our last lecture already I solved this. तुम्ही बोर व्हाल म्हणून मी फास्ट घेतलं. अगेन आय रिपीट स्लोली, डोंट वरी. हियर सपोज थ्री रेजिस्टन्सेस आर इन सिरीज अँड वन बॅटरी. ह्या बॅटरीचं पोटेन्शियल किती आहे V, आणि हे तीन असं क्लोज लूप फॉर्म झालेलं आहे R1 R2 R3 सिरीज. एका सरळ रेषे एका शेजारी एक. येस इंटू V. R3 अपॉन R1 प्लस R2 प्लस R3 इंटू V. आता बघा तिकडे अगेन आय एम रिवाइजिंग इन शॉर्ट. बॅटरी V आहे, कोणाच्या अक्रॉस लावली आहे? पूर्ण सिरीज कॉम्बिनेशनच्या. म्हणजे ह्या बॅटरीज ओव्हरऑल V इज इक्वल टू IR मध्ये काय येणार? V मुळे असणारा I, सिरीज मधनं जाणारा करंट काय असतो? सारखाच असतो. म्हणून I एवढाच करंट R1 मधनं असेल, I एवढाच करंट R2 मधून असेल, I एवढाच करंट R3 मधून असेल. Means I is the current through all resistances, equal magnitude of current. Only potential drop is different. Whenever there is a series combination, potential drop is different, but current through them is the same. So V1 is potential drop across R1, V2 is potential drop across R2, V3 is potential drop across R3. So what you write? V is equal to, here you have to write that V is equal to, write down this table. So V is equal to V1 plus V2 plus V3. Okay. So here, and you know, in our previous two lectures I told you that whenever resistances are in series, overall effective resistance or equivalent resistance RS is equal to R1 plus R2 plus R3, because they are in series. In parallel their reciprocals get added. Okay, so V is equal to what? Overall this V This V is the potential of this battery. Therefore, V is equal to I into Rs. What is the overall resistance? Rs. Therefore, V is equal to I into Rs. And like that, we write for V1. V1 is equal to I is the current through this resistance. Therefore, according to Ohm's law, V1 is equal to I into R2. According to Ohm's law, what about V2? V2 is equal to I into R2. V3 is equal to I into R3. According to that, we write all these steps. But we want actual formula for V1 without current I. जर currentची magnitude माहिती नसेल, then also we able to calculate V1, V2, V3 with the help of R1, R2, R3 and potential of battery. ओव्हरऑल किती पोटेन्शियल अप्लाय केलेलं आहे ते जर माहिती असेल आणि आपल्याला R1, R2, R3 च्या व्हॅल्यूज माहिती असतील तर आपण V1, V2, V3 काढू शकतो. जरी आपल्याला करंट माहिती नसेल तरी इथे ह्या फॉर्म्युलीज साठी हे पण V1, V2, V3 चीच फॉर्म्युलीज आहे, पण याच्यामध्ये करंट इज नेसेसरी. करंट माहिती नसेल तरी आपल्याला काढता यायला पाहिजे. म्हणून मग आपण जस्ट काय केलं, this upon this. सपोज असं घेऊ शकतो की नाही आपण. सपोज दिस इज युअर इक्वेशन नंबर 1, 2, 3, 4. So suppose this is your equation number, this is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. So what you write here, dividing equation 2 by 1. असं करू शकतो की नाही, dividing equation 2 by 1. So what is your LHS? V1 upon V is equal to IR1 upon IRS. So here I cancel. Therefore V1 is equal to R1 upon RS, and that V at denominator is here in multiplication. So what we get, V1 is equal to R1 upon RS into V. So what is the value of RS? RS is equal to R1 plus R2 plus R3. So we insert here R1 plus R2 plus R3. So what is the formula for potential V1 across resistance R1? R1 upon R1 plus R2 plus R3 into V. Okay. So here, what about this? Now here dividing, what you write, dividing. Do you see this? No. Right there, in above that, right there, dividing equation 3 by 1. Above that, right, dividing equation 3 by 1. इथे काय लिहिणार? Dividing equation 3 by 1. Then we get V2. What is your third equation? V2. What is your first equation? V. Therefore V2 upon V is your LHS. And what is your RHS? IR2 upon IRS. IR2 upon IRS. Therefore current I from numerator and denominator cancels. Therefore V2 upon V is equal to R2 upon RS. Right? Therefore V2 is equal to R2 upon, in place of RS again we insert from this equation. We already know that series resistance is given by R1 plus R2 plus R3. So we replace this RS by R1 plus R2 plus R3. Therefore V2 is equal to R2 upon R1 plus R2 plus R3 into V. This V at numerator here multiplying by V. This is the formula for V2. Now what is V3? Before going to that, what you have to write here, dividing equation 4 by 1. Before this, you have to write dividing equation 4 by 1. So what is your fourth equation? V3 equal to IR3. What is your first equation? I is equal to IRS. V is equal to IRS. So V is equal to IRS. So again I cancel. Then this equation becomes V3 upon V is equal to R3 upon RS. R3 upon RS. Therefore, V3 is equal to R3 upon R1 plus R2 plus R3 into V. Right? This is the equation for V3. In this way, we get the equations for V1, V2 and V3 without I, independent of I. या तीनही इक्वेशन मध्ये करंट माहिती असण्याची गरज नाही. म्हणजे करंट माहिती नसेल तरी पण आपण इंडिव्हिज्युअल पोटेन्शियल कॅल्क्युलेट करू शकतो. ओके, डज एव्हरीवन अंडरस्टँड नाव? येस येस येस, राईट. Sanskriti, right equation. But you have to insert bracket here. R1, R2, R3 ला bracket घालावं लागेल ना. तू जसं असं लिहिलंय ना, R3 upon R1 plus R2 plus R3, तर याला bracket घालावं लागेल. V3 equal to आणि मग multiply by V. Bracket is important. Otherwise R3 is considered at the. Okay, Gaurav. Okay, everyone understand this, I think now. So whenever the resistances are in series, you must know the formula for potential division. Now I am giving you one numerical. First I am going to simplify and then I am giving you one. Okay, or before that I am going to explain you one important theory concept. जी की आपल्याला लागणार आहे आणि मग त्याच्याच रिलेटेड एक न्यूमेरिकल आपण सॉल्व्ह करूया अदर दॅन युअर टेक्स्टबुक. टेक्स्टबुक मध्ये ज्या मेथडने दिले त्याच्यापेक्षा सोप्या मेथडने आपल्याला सॉल्व्ह करायचं आहे. म्हणूनच तुम्हाला मी करंट पोटेन्शियल डिव्हिजन आधी शिकवली. ओके, नाउ वी गो बॅक टू वन पॉइंट ऑफ अवर टेक्स्टबुक, दॅट इज द इंटरनल रेजिस्टन्स ऑफ द सेल. Every cell having internal resistance. Now this cell is connected here. Now what is the external resistance of the circuit? Rs. You easily understand Rs. V is equal to IR. Therefore Rs is the total resistance of the circuit, where Rs is equal to R1 plus R2 plus R3. Okay, but what is the internal resistance? There are two, means anode and cathode of the cell. From anode to cathode, that overall resistance is Rs. But what about that cathode to anode? Whenever electrons moves from that anode to cathode, that electrolyte is there or whatever is there, some obstacle is there, and they oppose some, means they has to face some opposition, that is known as the internal resistance of the cell. Means every battery having some internal resistance, that is very small value, but there is some internal resistance. Remember this. कुठल्याही बॅटरीला तुम्ही स्कूल लेवलला ते डॅनियल लॅक्लान सेल लॅबोरेटरी मध्ये केमिस्ट्रीच्या शिकल्यात, आठवतंय? इलेक्ट्रोलाइट असेल, एक रॉड टाकलेला असेल निगेटिव्ह इलेक्ट्रोड, एक पॉझिटिव्ह इलेक्ट्रोड असेल, अँड एक्सटर्नली यू कनेक्ट द वायर फ्रॉम एनोड टू कॅथोड. So that wire having some resistance, or that resistance you connect in external path, that is your external resistance. But internally, whenever that charges or cations move from anode to cathode, yes, anode to cathode, at that time they must face some opposition, that is known as the internal resistance of the cell. The value of internal resistance is very small. खूप कमी असणार आहे ती व्हॅल्यू, कमी अपोजिशन असणार आहे, but still some opposition is there. So whenever there is a 3 volt battery, you cannot get 3 volt exactly. It is less than 2.99, 2.98, sometimes 2.8, depends upon that opposition. Practically, do you understand that internal resistance? So General equation of Ohm's law, V is equal to IR, where R is the external resistance. But whenever there is that every battery having some internal resistance, that is termed as the RS, source resistance. Internally present, but you consider that is the source resistance, and that is here at which we connect the output. If we consider the output here across that load resistance, that is termed as a VAB. VAB output voltage, that is also considered sometimes terminal voltage, that is sometimes considered as output voltage. Here suppose this end is A and this end is B. Okay, so voltage across AB, it is also termed as a terminal voltage, it is also termed as output voltage, it is also termed as a load voltage. All this काही बुक मध्ये त्याला VAB म्हटलं असेल. Voltage across point A and B, voltage across load resistance, that is why load voltage. Voltage across these two terminals, that's why terminal voltage. Output voltage, that's why output voltage V0. Suppose we connect here 5 volt battery, then what we expect? All these voltage near about exactly 5 volt. But what happens exactly? ही diagram मी आता थोडी अशी काढणार. Listen carefully, all of you. Okay, then download the app. So here, this is the positive of battery, this is the negative of battery. Means what we expect 5 volt, but surely we get less than 5 volt. Why? Because this potential drop across this V 5 volt drop across some internal resistance and maximum across that load resistance. Okay, means small voltage. Suppose here this is very less value. This is near about 2 ohm only. Okay, and this is suppose 100 ohm. So very small voltage drop across this. Means so we draw here. I am starting with this positive of battery. Here your negative of battery. Here your RS. Here your RL. Or for it थोड़ा वेळ मी परत तसाच काढणार. Here your RS, here your RL, and we want this voltage. This voltage is your V2, this is your V, this is your V1. Means this one is like your potential division. This V is equal to 5 volt is divided somewhat across this resistance and somewhat across this load resistance. So what you have to say? V is equal to V1 plus V2, right? V is equal to V1 plus V2, and what is the formula for V1? RS upon RS plus RL into V. What is the formula? 999. Don't draw. Try to understand. Each and every word is important. खूप स्लो घेणार आहे मी हे सगळं. It's so simple. पण हे आलं की तुम्हाला पुढे मला जास्ती त्रास नाही लागणार तुम्हाला समजवायला आणि तुम्हालाही समजण्याला टू अंडरस्टँडिंग ऑल द कन्सेप्ट. नेक्स्ट कन्सेप्ट म्हणजेच नेहमी सिरीज रेजिस्टन्सेस साधे सोपे असेच असतील का? नाही. दीज आर मीन्स these two, suppose this is your RS and this is your RL. Not necessary always name of the resistance is R1 and R2. So here this RS and RL both are in series. असे दिसताय तरी पण ही these are the flexible wire. ही वायर मी अशी करू शकते की नाही? So RS and RL are in a series. Do you understand this? These both resistances not necessary always in straight line, that these two are in series, means in this closed loop these two resistances are in series. Therefore, V is equal to V1 plus V2. So how you calculate V1? V1 is equal to, what is the formula for V1? V1 is equal to RS upon RS plus RL. Because now RS is your R1 and RL is your R2. Multiply by V. This is the formula for V1. And how you calculate V2? V2 you calculate like this. RL upon RS plus RL into V. Okay? Means in this way, ह्या V2 ला आता काय वेगवेगळे नाव आहेत आपल्याकडे. V2, suppose this terminal is A and this terminal is B. In place of V2, you may write VAB. You may write output voltage V0. You may write it is load voltage. Or you may write it is a terminal voltage. म्हणजे त्याला काय नाव दिलंय हे मॅटर करत नाही. तो कुठल्या पोझिशनला आहे आणि त्याच्या अक्रॉसचा पोटेन्शियल ड्रॉप हा पोटेन्शियल डिव्हिजनच्या फॉर्म्युल्याने कसा काढायचा, दॅट इज इम्पॉर्टंट. मीन्स यू नाउ अंडरस्टँड पोटेन्शियल डिव्हिजन. ती आपल्याला इम्प्लिमेंट पण करता यायला पाहिजे. तो फॉर्म्युला कुठेही दोन रेजिस्टन्स किंवा दोनापेक्षा जास्ती रेजिस्टन्स सिरीज मध्ये असेल तर इंडिव्हिज्युअल रेजिस्टन्सच्या अक्रॉसचा पोटेन्शियल ड्रॉप आपल्याला काढता यायला पाहिजे. त्याच्यासाठी पोटेन्शियल डिव्हिजनचा फॉर्म्युला वापरताना नावं बदलू शकता. Not necessary always the name is R1, R2, R3. In place of R1 there may be RS. In place of R2 there may be RL. Okay. So in this diagram your RS and RL. So draw this diagram. Don't draw this diagram and write down the heading as internal resistance of the cell. Internal resistance of the cell. Everyone understand internal resistance? So V is equal to IR, that is the Ohm's law, but general equation of whenever there is a EMF, potential drop, and EMF are two different concepts. EMF means electromotive force. EMF असं लिहिता की नाही तुम्ही? Which is equal to IR plus I into small r. Whenever cell is there at that time, in terms of potential V, in place of potential V, you have to consider EMF. मग EMF जर कन्सिडर करायचा असेल तर त्यावेळी इंटरनल रेजिस्टन्स पण कन्सिडर करावा लागेल तुम्हाला. म्हणून EMF चा फॉर्म्युला काय असतो? I into external resistance R, I into internal resistance small r. Therefore, general equation of Ohm's law says that I into capital R plus small r, where E is the EMF of the cell, I is the current due to that cell, R is the external resistance, capital R is the external resistance and small r is the internal resistance of the cell. समजलं का आता सगळ्यांना? आणि इंटरनल रेजिस्टन्स म्हणजे रेजिस्टन्सच असणार आहे. रेजिस्टन्स म्हणजे रेजिस्टन्सच, अपोजिशन ऑफर्ड टू द फ्लो ऑफ करंट. पूर्ण ब्लॉक नाही करत पण तो काही प्रमाणात त्याला अपोज करतो. स्पीड कमी होतो. रेजिस्टन्स जास्ती असला की त्याचा करंटचं स्पीड काय होणार आहे? कमी होणार आहे. ओके. सो द रेजिस्टन्स इज अपोजिशन ऑफर्ड टू द फ्लो ऑफ करंट. मग ह्या पॉझिटिव्ह इलेक्ट्रॉन्स पॉझिटिव्ह ऑफ battery and this one is a suppose negative. This positive is greater height, negative. Electrons start from this negative of battery towards the positive of battery. Okay. So that is the external path, but they has to complete the cycle. They complete from positive to negative येताना आतमध्ये एवढ्याशा डिस्टन्सला पण त्यांना काही अपोजिशन ऑफर करावं लागेल. That is nothing but the internal resistance of the cell. That is nothing but the internal resistance of the cell. Okay. So that is the small r. Though it is having very little value, physically not present. तो प्रत्यक्ष तिथे ऍक्च्युअल कनेक्ट केला नसेल पण तो त्या सेल मध्ये सेलला स्वतःचा काहीतरी रेजिस्टन्स असतो. त्याला आपण काय म्हणणार? इंटरनल रेजिस्टन्स ऑफ द सेल. म्हणजेच काही रेजिस्टन्स आला की त्याच्या अक्रॉस पोटेन्शियल ड्रॉप होणारच. म्हणून मग हा 5 जर घेतला 5 वोल्टच्या बॅटरीच्या अक्रॉस डायरेक्टली तुम्हाला 5 वोल्ट नाही मिळणार. इट इज स्लाइटली लेस दॅन 5 ड्यू टू दॅट इंटरनल रेजिस्टन्स बिकॉज सम पोटेन्शियल. समजा इथे 4.9 मिळालं तर 0.1 वोल्ट कुठे ड्रॉप होणार आहे ह्या रेजिस्टन्सच्या अक्रॉस. म्हणजे V इज इक्वल टू V1 प्लस V2. Therefore 5 is equal to what is this? This is 4.9 and this is 0.1. So when you measure across this external resistance, what you get? 4.9. That is for example, not exact values. या ज्या सांगते आहे त्या फॉर एक्झाम्पल सांगते. म्हणजे जेवढी बॅटरीचं पोटेन्शियल येतं ते सगळं आपल्याला टर्मिनल व्होल्टेजला मिळावं नाही. आणि हे सोर्स याला काय म्हणणार आहे आपण आता नावं लक्षात ठेवा नीट. अगेन आय एम रिपीटिंग so many times. This one is a source voltage. बॅटरीच्या पोटेन्शियल आपण काय म्हणणार आहे सोर्स व्होल्टेज. आणि याला आपण काय म्हणणार आहे टर्मिनल व्होल्टेज, आउटपुट व्होल्टेज, लोड व्होल्टेज किंवा VAB. समजलं? इज इट क्लिअर टू एव्हरीवन नाउ? ड्रॉ दिस डायग्राम. Not nature of electrodes, Rupesh. इलेक्ट्रोलाइट. थिक इलेक्ट्रोलाइट असेल, मोर नंबर ऑफ मॉलिक्युल्स, देन अपोजिशन इज मोर. किंवा ते कंडक्टिंग असेल, कंडक्टिंग मटेरियल असेल तर ते इझिली स्पीडने इलेक्ट्रॉन्स हे एनोड पासून कॅथोड पर्यंत जाऊ शकतील सहज. मुवमेंट ऑफ चार्ज कॅरियर्स इझिली पॉसिबल असेल. दॅट डिपेंड्स, इलेक्ट्रोलिसिस डिपेंड्स अपॉन. लर्न केलेलं असेल बघा आन्सर तुम्ही. टेम्परेचर ऑफ द इलेक्ट्रोलाइट. येस, डू यू रिमेंबर? ऑन विच फॅक्टर्स दॅट द स्पीड ऑफ इलेक्ट्रोलिसिस डिपेंड्स. दॅट टेम्परेचर ऑफ इलेक्ट्रोलाइट. आणि अजून काय असतं त्याला कॉन्सन्ट्रेशन ऑफ इलेक्ट्रोलाइट. राईट, कॉन्सन्ट्रेशन ऑफ इलेक्ट्रोलाइट. ऑल दिस थिंग्स मॅटर्स. म्हणजेच तुम्ही आता कन्सेप्ट साठी मेन गोष्ट काय लक्षात ठेवायची, एका इलेक्ट्रोड पासून दुसऱ्या इलेक्ट्रोड मध्ये पर्यंत त्या इलेक्ट्रॉन्सला किंवा चार्ज कॅरियर्सला पोहोचायचं असतं. आणि ते पोहोचण्यासाठी त्यांना जे ऑपोजिशन फेस करावं लागतं त्याला त्या सेलचा काय म्हणतात इंटरनल रेजिस्टन्स ऑफ द सेल. ओके, सो वी ट्राय टू सिम्प्लिफाय वन न्यूमेरिकल टू फाइंड द इंटरनल रेजिस्टन्स ऑफ द सेल. पण तुम्ही ह्या इंटरनल रेजिस्टन्स ऑफ द सेल काढण्यासाठी मी तुम्हाला कशाची हेल्प घ्यायला सांगणार आहे? पोटेन्शियल डिव्हिजनच्या फॉर्म्युलाची. म्हणजे दोन रेजिस्टन्सेस जर सिरीज मध्ये असेल तर याच्या अक्रॉसचा पोटेन्शियल ड्रॉप काढायचा असेल, R1 असेल आणि हा R2 असेल तर V1 इज इक्वल टू काय येणार? R1 अपॉन R1 प्लस R2 इंटू V. आणि इकडे V2 इक्वल टू काय येणार? R2 अपॉन R1 प्लस R2 इंटू V. नाउ write down one numerical. Those who are having textbook, आपण वेगळ्या पद्धतीने सॉल्व करणार आहे. ज्यांच्याकडे टेक्स्टबुक आहे त्यांनी पेज नंबर 11 बघा. पेज नंबर 11. A generator has an open circuit EMF of 20 volt. Those who are not having textbook, try to write down this numerical आणि घेऊन टाकायचं आहे लवकर हा टेक्स्टबुक आपलं. पेज नंबर 11. सॉल्व करू नका त्यांनी जसं दिलंय त्याच्यापेक्षा सोप्या पद्धतीने आपण सॉल्व करणार आहोत. सो राइट डाउन अ जनरेटर हॅज ओपन सर्किट EMF ऑफ 20 वोल्ट. Open circuit EMF, that is nothing but a source voltage. What they say, a generator has an open circuit EMF of 20 volt. Full stop. Its internal voltage dropped to 16 volt with RL of 40 ohm. sorry, its terminal voltage drop. Means terminal voltage is given. Terminal voltage is given 16 volt and RL of terminal voltage across load resistance of 40 ohm. Calculate internal resistance. Calculate internal resistance. Calculate internal resistance. Now from this, if diagram is not given, we try to calculate, try to draw first diagram. Here Vs open circuit EMF is given 20 volt. Internal resistance ला म्हणूया आपण source resistance. Here this is your Vs is equal to 20 volt. Load resistance is given. Here your RL is given, which is 40 ohm. And these are in series only. Page number 11. Okay. So RS is equal to what? RL is given 40 ohm. 40 ohm is given, and terminal voltage, this voltage is given. This is termed as here terminal voltage. आता इथे जर तुम्ही A आणि B नाव दिलं त्याला VAB पण म्हणू शकता, VL पण म्हणू शकता, व्होल्टेज अक्रॉस VRL पण म्हणू शकता, व्होल्टेज अक्रॉस लोड रेजिस्टन्स RL और टर्मिनल व्होल्टेज इक्वल टू 16 व्होल्ट. ओके. आता ही डायग्राम मी तुम्हाला सोपी करून दाखवणार. बघा, यू मे राइट दिस डायग्राम लाइक दिस. दिस इज युअर 20 volt, this is your RS, this is your RL, and RL is nothing but VT, terminal voltage. So how you calculate? I is the current, due to that here I is the current. Therefore how you calculate? So voltage across load resistance VT or VRL is equal to RL upon RS plus RL multiply by Vs. Is it right formula? By potential division, we may write that terminal voltage means this is your R1 and this is your R2. How you write R2? R2 upon R1 plus R2 into V. So I write here according to our diagram RL upon RS plus RL into Vs. Right? Everyone understand this? सो हियर प्रत्येक वेळी अशी डायग्राम काढून घ्यायची गरज नाही. तुम्हाला आपोआप मनामध्ये डायग्राम बनवता यायला पाहिजे. याच्या अक्रॉसचं व्होल्टेज दिलंय, दिस इज युअर V2, म्हणजेच दिस रेजिस्टन्स अपॉन दिस प्लस दिस इनटू दिस. ओके. सो वी इन्सर्ट द व्हॅल्यूज हियर. VT इज इक्वल टू व्हॉट? VT इक्वल टू काय दिलाय आपल्याला? 16. 16 इक्वल टू व्हॉट इज अवर RL? 40 upon RS plus RL multiply Vs is what? 20. Therefore 16 upon 20, or we write 16 multiply RS plus RL is what? 40. Now above that only mathematical calculation. Only one unknown is there in your equation. Now you easily simplify mathematically. पुढच्या mathematical step मला explain करायची गरज नाही, तुम्हाला सहज काढता येईल. Okay. So how you write? RS plus 40 is equal to 800 upon 60, which is equal to 50. So what is the value of RS? 50 minus 40 is equal to 10 ohm. So our internal resistance RS is equal to 10 ohm. See the answer in your textbook. They try to simplify in different manner because up to that point that potential division formula is not introduced. That's why between two steps by different calculations or lengthy calculation they simplify. That is quite difficult to understand, but their answer is also 10 ohms. Please check the answer. Is it right? Do you understand? Does everyone understand this? Yes, methods are different only. सोपं वाटलं की नाही तुम्हाला? म्हणून मी आधी तुम्हाला पोटेन्शियल डिव्हिजन शिकवली. म्हणजे असं नुसतं न्यूमेरिकल दिलं आणि हा डायग्राम काही नसेल तरी पण तुम्हाला सॉल्व करता यायला पाहिजे. बिकॉज इंटरनल रेजिस्टन्स इज ऑलवेज इन सिरीज विथ दॅट लोड रेजिस्टन्स. इंटरनल रेजिस्टन्स त्या सेलचा त्या सर्किटच्या लोड रेजिस्टन्सच्या नेहमी काय असतो? सिरीज मध्येच असतो. एक लॉजिक तुम्हाला माहिती पाहिजे आणि पोटेन्शियल डिव्हिजन माहिती पाहिजे. देन यू इझिली सिम्प्लिफाय बाय दिस मेथड. ओके. डू यू कंप्लीट? Okay, very good. Now next one. See on page number 11. Second numerical is given. I am going to read that. Those who are having textbook, see in your textbook. Or remaining student are to write down this numerical. I am going to dictate that page number 11, problem 4. A DC source has no load voltage of 5 volt. 5 volt. A DC source has no load voltage of 5 volt and internal resistance of 2 ohm. And internal resistance of 2 ohm. Full stop. It is connected to the load resistance RL. R suffix L. It is connected to a load resistance RL that can vary from 2 ohm to 12 ohm. RL ची एकच व्हॅल्यू नाही दिलेली. RL कधी कधी 2 ohm असू शकतो आणि जास्तीत जास्त तो किती असू शकतो? 12 ohm. Means what they said, it is connected to a load resistance RL that can vary from vary from 2 ohm to 12 ohm. Full stop. Find the variation in terminal voltage of the source. Find the variation in the terminal voltage of the source. Now listen. Resistance, you understand there are different type of resistances, fixed resistances and variable resistances. काही रेजिस्टन्सेस असे असतात की त्यांना स्वतःची फिक्स व्हॅल्यू असते, पण काही रेजिस्टन्सेस असे असतात की त्याचा नॉब व्हॅरी केला की त्याच्या वेगवेगळ्या व्हॅल्यूज बदलू शकतात. व्हेरिएबल रेजिस्टन्स बिकॉज अकॉर्डिंग टू द रिक्वायरमेंट ऑफ द सर्किट sometimes we use fixed resistance and sometimes there is a necessity of variable resistances. In volts इंटरनल रेजिस्टन्स ची व्हॅल्यू काढायला सांगितली होती ना, मग तो रेजिस्टन्स 10 ओहम. V1 किती येणार? RS च्या अक्रॉसचा पोटेन्शियल ड्रॉप बघा 4 येणार ना, 4. सोपं. कोणी विचारलं आता? ask me last question, right question है. गौरव. ओके, येस गौरव. बघा, 20 वोल्टची बॅटरी जर लावली तर तुम्ही एक्सपेक्ट काय कराल, आउटपुटला 20 वोल्ट्स मिळायला पाहिजे, पण तुमची बॅटरी किती देते आता, 16 वोल्ट ओनली. मग 4 वोल्ट कुठे ड्रॉप होतोय, रिमेनिंग 4 वोल्ट कुठे जात आहे, इंटरनल रेजिस्टन्सच्या अक्रॉस. डू यू अंडरस्टँड? बिकॉज V is equal to V1 plus V2. So what is your V1? Potential drop across internal resistance. What is the potential drop across external resistance? Output voltage given by that source of battery is 16 volt only. So what is where that 4 volts, remaining 4 volts, that is across the internal resistance of battery. Do you understand, Gaurav? Gaurav, do you understand? Are you there, Gaurav? Okay. Now next numerical. See that next numerical diagram is also given. Internal resistance or one series resistance is of 2 ohm and another RL, that is variable resistance, it is 2 ohm. That is 2 ohm and 12 ohm. 2 ohm to 12 ohm. So two terminal voltage or two output voltage, there are two V2. 2 V2 means V is equal to V1 plus V2, you know. आणि V21 आणि V22 असं येईल, किंवा VT1 टर्मिनल व्होल्टेज 1 and okay. How I am going to refresh? Okay, I am going to see your charts now. Okay. Now in this numerical, that load resistance पहिल्याने VT1 काढताना काय करायचं आहे आपल्याला, RL ची व्हॅल्यू काय घ्यायची आहे, 2 ओहम, आणि VT2 काढताना RL ची व्हॅल्यू काय घ्यायची आहे, 12 ओहम. म्हणजेच तुम्हाला VT1 मिळेल आणि VT2 पण मिळेल, दोन प्रकारचे टर्मिनल व्होल्टेज मिळतील. म्हणजे जो तुम्ही सपोज R1 and R2 are the two resistances connected in series. Suppose R2 having two different values, whenever the knob is on lowest position, at that time that is your RT1, and whenever the knob is on highest position at this time, that resistance is 12 ohm, that is RT2. Better example of this हे केव्हा समजेल तुम्हाला, लक्षात आहे इकडे सगळ्यांनी बघा. You know your regulator, फॅन्स रेग्युलेटर, फॅनचं रेग्युलेटर माहिती आहे तुम्हाला, कधी स्मूथ व्हॅरिएशन असतं किंवा असं खटकीने तुम्ही फिरवता, दॅट इज द नॉब स्विच, टाइप ऑफ स्विच. व्हॉट इज देयर इज अ व्हेरिएबल रेजिस्टन्स. Variable resistance, whenever that knob is on first position, your fan swings, rotates with minimum speed. Okay, at that time there is a maximum resistance overall. When you connect here first position, now here when you connect here, overall all these roots resistance is in your circuit. That's why the minimum current, I minimum. Okay, so your speed is less. When you increase the knob of that regulator on that second position, at that time means this potential, this regulator is nothing but a variable resistor. तुमच्या फॅनच्या रेग्युलेटर मध्ये स्मूथ व्हॅरिएशन असेल किंवा नॉब असेल, तो काय असतो, एक प्रकारचा पोटेन्शिओमीटर, व्हेरिएबल रेजिस्टन्स. as we go on decreasing the resistance, current increases, current to your fan, supply to your fan increases, and due to that speed of that fan increases. So as you go, if you keep the knob on fourth position, then only the resistance from this point to this point, एवढाच resistance असेल, minimum resistance. A position offered is minimum. That's why maximum current. Whenever resistance is minimum, current is maximum. So maximum current is provided to that fan, and speed of that fan increases. Means that your regulator is nothing but a potentiometer or variable resistance. Okay, so like that, here in our example, latest example, there is a variable resistance having two knobs only, R1 and RT1 and RT2. RT1 काय असू शकतो, एका पोझिशनला मिनिमम 2 ओहम असू शकतो, मॅक्झिमम किती असेल 12 ओहम. इन बिटवीन दॅट काही पण व्हॅल्यू करायला त्याला चान्स असू शकतो. पण मग आपण मिनिमम, जर तो मिनिमम पोझिशनला असेल तर आपल्याला किती व्होल्टेज मिळेल, आणि मॅक्झिमम पोझिशनला मॅक्झिमम पोझिशनला असेल त्यावेळी आपल्याला किती व्होल्टेज मिळेल, दॅट दे आस्क टू कॅल्क्युलेट. डू यू अंडरस्टँड? सो फर्स्ट होईल केव्हाही कुठलंही न्यूमेरिकल, लिसन केअरफुली ऑल ऑफ यू, इम्पॉर्टंट, आय एम गोइंग टू टेल यू. केव्हाही कुठलंही न्यूमेरिकल सॉल्व करण्याआधी रीड 2 times प्रॉपरली. Next step, you have to write down given data properly. What is given in that numerical and what you are asked to calculate. काय दिलेलं आहे आणि काय काढायचं आहे ते आधी बघायचं आहे, आणि मग त्याच्या रिलेटेड फॉर्म्युला तर आपल्याला कळूनच जातो. Okay, so first we read that numerical again and try to write down the given data. So what they say, a DC source has no load voltage Now no load voltage, this word is also new for you. No load voltage means open circuit battery. बॅटरीचे दोनही टर्मिनल ओपन आहे. इथे लोड रेजिस्टन्स कनेक्ट केला की त्याच्या अक्रॉसचा पोटेन्शियल ड्रॉप कमी होणार. किती वोल्टची, 5 वोल्टची बॅटरी असेल. नो लोड व्होल्टेज म्हणजे लोड रेजिस्टन्स कनेक्ट केलेला नाही, ओपन सर्किट व्होल्टेज, दॅट इज द सोर्स व्होल्टेज. नो लोड व्होल्टेज मीन्स व्हॉट? Okay, so after that what they say, an internal resistance of 2 ohm. Internal resistance is nothing but source resistance. It is supposed 2 ohm. Okay, it is connected to the load resistance RL that can vary from 2 ohm to 12 ohm. So load resistance minimum is 2 ohm and load resistance maximum is 12 ohm. And find the variation in terminal voltage of the source. Find VT1 and VT2 terminal voltage, output voltage they are asked to calculate. So how you calculate? Now we know that formula. Draw that diagram. Given variable resistance, symbol for variable resistance is like this. This is 5 volt battery. This RS is 2 ohm. This is 2 ohm to 12 ohm. Okay. So from this diagram, this is your RL. So VT1 is equal to, याच्या across चा कसा काढणार? This resistance upon this plus this into this. So RL1 upon RS plus RL1 multiply by VS. And how you calculate VT2? VT2 is equal to RL2 upon RL plus RL2 multiply by VS. Now insert the values. And Simplify. Okay, do you understand? Do you have any problem in video or audio? Are you there? Any difficulty? Okay, try to simplify. I am given both the formulas. You know RL1 is 2, RS and RL1 into VS. So insert the values. So terminal voltage 1, RL1 is 2 upon 2 plus 2 multiply VS is what, 5 volt. Therefore VT1 is equal to 10 upon 4. What about VT2? VT2 is equal to RL2 is 12 ohm, RS is equal to 2 plus 12 multiply by 5. Therefore VT2 is equal to 60 upon 14. VT2 is equal to means terminal voltage. Yes. Terminal voltage varies from 2.5 to 4.285. Whenever load resistance is minimum, terminal voltage is also minimum, because at that time more potential drop across internal resistance, and terminal, whenever the load resistance increases, that terminal voltage also increases. 4.285. Remember, always try to find out the answer up to 3 decimal to improve the accuracy. 4.28 is also the right answer. Okay, see in your textbook, this is your solved example. Okay, this is also the small solved example in your textbook. 285. Okay, so write down the answer in words, that the variation in terminal voltage is from 2.5 volt to, therefore write down this variation in terminal voltage is from 2.5 volt to 4.285 volt. Okay, does everyone understand this? Now we are going to simplify exercise numerical. That is unsolved in your textbook. Go on page number 36. Page number 36. A DC source has, all of you complete this. झालंय सगळ्यांचं? They also calculate terminal voltage in percentage. So how you calculate percentage? Percentage variation in VT is equal to maximum voltage upon minimum upon maximum. What is the maximum voltage? Maximum VT 2 minus 2.5 upon maximum multiply by 100. Therefore, what you get? 1.785 upon 4.285. So in short, approximately we may write 1.8 upon here 4.3. Therefore 43, 18 by 43. So how much percent? $41.67. Multiply by 100. 100 means 180 upon, or you write 18 na, suppose 100 upon 43, which is equal to answer given 41.67%. Percentage variation in terminal voltage is 41.67%. Remember, calculator is not allowed, so you must simplify by your own way. Mathematical calculations आपल्याला करता यायला पाहिजे. And remember one thing, for 50 marks there are 3 hours for paper 1, and on next day or day after tomorrow there is a paper 2 of electronics. For 50 marks again there are 3 hours, means there is a sufficient timing, because you have to write lengthy answers, draw some circuit diagrams, derivations and numericals are there. Okay, so 3 hours for 50 marks, so we have to write proper answers. Okay, so that exercise first numerical is homework for you. Let us see how many of you are able to simplify that numerical in proper way. See that, mark that numerical, page number 36. Problems for practice. First numerical, I am going to read that. A DC source has no load voltage of 3 volt. Means Vs given, Vs is equal to, write down given data. Vs is equal to 3 volt and internal resistance of 2 ohm. Therefore, Rs is equal to 2 ohm. It is connected to the load resistance RL that varies from 4 ohm to 10 ohm. Means RL1 is equal to 4, RL2 is equal to 10. Find the variation in terminal voltage of the source. Find VT1 is equal to what and VT2 is equal to what. In this way, you calculate by using this similar formulas, VT1 and VT2. And then find out percentage variation in terminal voltage, maximum minus minimum upon maximum, multiply by 100 to find out the percentage variation. Okay, करता येईल सॉल्व. ट्राय टू सिम्प्लिफाय. मला माहिती आहे येईल सगळ्यांना. Yes, I am repeating that question. A DC source has no load voltage of 3 volt. A DC source has no load voltage of 3 volt and internal resistance of 2 ohm. Full stop. It is connected to a load resistance RL capital R suffix L. It is connected to a load resistance RL that can vary from 4 ohm to 10 ohm. 4 ohm to 10 ohm. Full stop. Find the variation in the terminal voltage of the source. Find the variation in terminal voltage of the source. And I just told you given data also. RL1 2 RL2 RL1 4 ohm आहे इकडे RL2 किती आहे 10 ohm. इंटरनल रेजिस्टन्सला RS म्हणा. सोर्स नो लोड व्होल्टेज म्हणजे सोर्स व्होल्टेज. Okay, are you ready? Try to simplify. We'll see you in our next lecture at the same time. Try to attend live lectures. We are having 100 marks practical also. I have to give you 100 marks. So remember that thing, internal 100 marks. So be present in every lecture. Okay? Okay. Do you have any difficulty? Do you want to ask anything? Okay? Then we will meet tomorrow at the same time. Okay?